Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. So today we are going to look at a new topic, which is trimetric projection and foreshortening ratios. So let's read the question first. Consider a unit cube with the standard position with its vertices at 0, 0, 0, b 1, 0, 0, and so on and so forth. Just a unit cube, right? That's what we are dealing with. Perform a trimetric projection of the cube when the view direction is along the negative z axis. Consider the rotation angles of theta equals 30 and phi equals 60 about y and x axis respectively. Okay, so first we will understand what is trimetric projection. So it's a way of representation for 3D objects, like in a distorted, or let's say how it will behave when we move the viewing position far away or closer to the object. So that's what it is, but it will be ultimately represented on a plane drawing surface. Okay, so if we see the problem which is given above, so we have the location of the view towards the negative z axis, and this is how we are looking at the cube. Okay, and it is a unit cube, so all the vertices will be marked as per it is given in the question. Okay, now like what are the steps that we are going to follow here? So first we will rotate about the y axis with the angle it is given in question. Then we will perform the rotation about the x axis, and finally we will perform the orthographic projection about the z equal to 0 plane. So these are the steps we will need to follow in order to perform a trimetric projection. Okay, so the transformation matrix will be like this. So first it's y, so you see the second column and the second row is kept as it is, right? Similarly for rotation about the x axis, so this will be the matrix for that, and this is the projection about the z axis, so it will be like this. So for y axis and x axis, again the respective columns and rows will become 0, so you can perform like that. Perfect. Now we will put in the values in here and then like multiply these two, we get this particular matrix, and then finally multiply it with the orthographic projection, we get this as the final transformation matrix. Okay, now we have found the transformation matrix, so now we will determine the resultant coordinates of the cube. So in that case, these are the original matrix of the cube, so it is for the x coordinate, y coordinate, z coordinate, and it is the constant of homogeneity 1, because we are dealing with homogeneous coordinates. So when we multiply, so you see it is a 8 cross 4 matrix, and this is a 4 cross 4 matrix, so the resultant will be again 8 cross 4. So we will simply do matrix multiplication, we will find out this particular matrix, which is the transformed matrix after the trimetric projection. Okay, so I have not done the calculation for the second row, but it's quite easy, you can do it. So that's what it is for like the trimetric projection part. Now coming to the next part, which is foreshortening. So foreshortening is like the rate at which the object appears smaller in relation to the distance that the viewer has from the object. Okay, so it's a measure of that. So as you can say that since the viewer can be at any angle, so it is calculated for all the three axes. Okay, so for that what we do, we first multiply it with like the standard matrix into the transformed matrix that we had from above, like this one. So we multiply these two, we get this particular matrix, and from here we will calculate the foreshortening ratios for each of the axes separately. So the first row is for the x axis, the second row is for the y axis, and the third row is for the z axis. So that's what we calculate here in magnitude. So we just simply square it and take the under root. So that's how you calculate the foreshortening ratios as well. So that's been it. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.